So if you understand how to find the first derivative of an implicit function, you're probably ready for this video. Again, an implicit function is a function that is defined maybe not in terms of y equals everything that has an x in it. This would be an implicit type form of an implicit, or I guess what I'm trying to say is this function right here could be written explicitly, but in this form it looks implicit. And so we're going to use a simple one to show you how to do a second derivative. So first, if you want to find the second derivative, you're going to have to find the first derivative. So we need to take the derivative of each side with respect to x. So that would be 2x minus 3y squared dy dx equals 0. And again, that's because the derivative of x squared with respect to x is just 2x. The derivative of y cubed with respect to x is bring the 3 down, rewrite the y, take 1 off the power, times the derivative of the inside, or the y, with respect to x. You only have to use the chain rule on the ones that are such that the letters don't match up. So if I want to take the derivative of x squared with respect to x, the letters are the same, you don't need the chain rule. Okay, so this is the first derivative. If you solve this for dy dx, I have negative 2x over negative 3y squared, which is, clean this up a little bit, 2x over 3y squared. So you want to get the first derivative as clean as you can before you take the derivative again, because once you take the derivative again, you're going to have, things are going to get really messy. So you want this to be as clean as you can. Okay, take the derivative of each side again, and that leaves me with the second derivative of y with respect to x on the left side. And the right side, this is a quotient, so I have to correctly execute the quotient rule, which is low d high minus high d low all over low low. So that would be 9y to the fourth. Again, make sure that you're doing the chain rule on the ones that have a y. Okay, and then you just want to clean this up. And also, the key is on the second derivative will usually have a dy dx in it. And this over here is what dy dx equals. So that means that all this stuff can be traded out for this dy dx. And that's the most important part to understand how to get this simplified as much as you can. So this will be 6y squared if you combine these, minus 12xy times whatever dy dx is, which is 2x over 3y squared. Again, I got this from over here. This red part that's circled is this part. And then, of course, 9y squared is still on the bottom. Just keep cleaning this up. So 6y squared minus tops times tops, bottoms times bottoms would be 24x squared y over 3y squared all over 9y squared. This right here will reduce. Of course, the y's will cancel a little bit. So I have 6y squared minus 8x squared over y. That's because 24 over 3 makes 8. X squared still on the top, a y on the bottom. All over 9y squared, which is a long division bar, means both of these up here are being divided by 9y squared, so that's 6y squared over 9y squared minus 8x squared over 9y cubed, and that's because when you have a divided by with another divided by, both of the things that are being divided by go on the bottom, and so y and 9y squared are both on the bottom. We want to get a common denominator so we can combine these. So this is a 9y cubed, this is 9y squared, so now we got 9y cubed on the bottom. But you can't just go around writing in a y wherever you want, so you got to do whatever you do to the bottom, you got to do to the top. So now I have 6y cubed over 9y. That would have actually reduced 9y cubed minus 8x squared over 9y cubed. It's a good thing we did not reduce this, because now we have a common denominator. Combine your tops, 6y cubed minus 8x squared over 9y cubed, and there's your answer. Notice that the answer is in terms of x and y, so if I had an ordered pair that I wanted to know specifically what is the second derivative of this function at a specific ordered pair, I could take that ordered pair and put it in down here at the bottom and find the derivative at that ordered pair. The derivative depends on the x and the y in this case. And so, for instance, if I had said find the derivative of this function at 1, 1, notice that 1 minus 1 does give me a 0. So this ordered pair is on this function. I would come down here and put a 1 and a 1 for my x and my y. So this would be 6 times 1 minus 8 times 1 over 9 times 1. And the second derivative at 1, 1 is 6 minus 8, which is negative 2 over 9. So that is how you do a second derivative implicitly.